trimester exam. Let's just start going. All right, Monday, the 6 of you are going to come into class and you are going to take the multiple choice calculator active part of the test. In class. In class, because in total I need you guys to test for 3.5 hours. And your math exam block is only 2.5 hours.
Oh.
So I've got to be able to get one of the sections done Monday, and the section that I'm choosing is multiple choice, calculator active. If you walk in on Monday without your calculator, you're going to see how much you can do in a calculator inactive environment. You'll have 17 questions and you'll have the full 50 minutes. Okay? Tuesday morning, we're going to be in the cafeteria together. Everybody, A, B, and B, C, you're going to take the multiple choice calculator inactive part. Everybody still with me?
So
That's the first 55 minutes. So that's A, B, and B, C. What happens next is going to be different for you guys, because they're going to do like the calculator active part of their exam. Not you all. You guys are going to start the free response. The 90-minute long free response. You are going to have, the 6 of you, because Roger I don't think will be back at that time. Okay? So 6 free response questions you're going to write for a solid 90 minutes.
hold on, is
Yes,
it?
sir.
So the first one is calculator inactive the entire time.
The first 2 questions are calculator active, so you'll have 30 minutes. So I'm going to have you guys like sit over on the side, and I'm going to like have like just different timing for you than the AB students. They're going to be working at a different pace than you guys are.
Like 2 questions, do you mean 2 multiple questions? Like,
No,
no,
I
no,
mean
Chapter, we'll
2
do-
free response questions that you'll have 30 minutes.
Good 6 free responses.
Followed by 4 more free response that you'll have another hour for.
So 15-minute question with a little subsection.
When it comes to the real day of the exam, 91 days from now, you're going to do calculator inactive for 55 minutes. Then you get a short break, like 2 minutes. And then you do calculator active for 50 minutes, multiple choice. Then you get a break, like 5 minutes there. Then 2 free response questions that are calculator active for 30 minutes. Then no break. Then 4 free response, no calculator questions.
Capital
You are going to go 3.5 to 4 hours straight. You're going to be leaking brain fluid. The will to live is going to leave you at some point. Exactly. Wait. Nathan's like, oh, I'm dead. Oh. Man down, man down. So this is our reality.
These are like benchmark.
I mean, my 5 hours.
Yes.
5 hours.
Except for you guys, it is your final exam. Your trimester exam.
Oh.
Okay. I have no doubt that all 7 of you are fully ready for this. It's going to be a good experience on Monday. Late Tuesday morning, you might want to die, but you know, Monday will be a good day. All right, so here's what I want.
Imagine if we have English on Tuesday too.
Then maybe, who knows? I don't know.
More language.
I don't know about these guys. No, that means you don't have it. Because you don't speak the English. I barely speak English. All right.
I think came from the country.
All right, friends, here we go. We got the rest of this period. We're going to focus on fundamental theorem of calculus and the second fundamental theorem of calculus. Take 2 minutes. Write them down. Write them down as entirely as you can. Try doing this without the survival guide. I need you to take attendance real quick and pick up homework. 2, 3. Okay. Good news is they're not going to ask you the names. It's got the fundamental theorem of calculus. That's f of d equals f of a plus the integral from a to b of f prime of x dx. Final value equals the initial value plus the total change. I'm going to always say it that way. Final, initial, total change. The other way that we sometimes write the fundamental theorem of calculus is what you did when we first learned about integration. You find the antiderivative and evaluate from a to b. So it's big F of b minus big F of a. Okay? The second fundamental theorem of calculus, that's the one that does this weird mixing together of like derivatives and integrals.
Derivative.
So you've got to start with the derivative
Or integral from
of
A
an
to
integral
X, or
from-
from A to a variable.
from a to a variable. And the important thing to remember about a,
With a constant.
it has to be a constant. If it's anything else, this isn't going to work. Derivative of the integral of a function, so normally it's f of t dt, and your final answer, f of x. The AB students just learned this the other day, and they were like, it's magic! All we have to do is change out the variable. Yes, that's pretty much it.
And then they get tricked.
And then they get tricked, because then they get to this one. The extended version. And they're normally okay with this part. They're like, oh, it's f of g of x times g prime.
Not chain rule.
Not chain rule, right? None of that stuff. Don't write that f prime. Get it out of there. Oh, Lord, now it's just messy. Okay, but again, a is a constant. Okay, strange things that I've seen, that I've done with these.
You switch the place of the constant.
The place of the constant, the fancy, the limits of integration. If I switch those limits, what happens?
Sign change.
The sign has to change, because when you change your limits of integration, you introduce a new negative sign. That's pretty much about it. That's about all I got. Okay, other than my favorite trick is when I ask you what that is and there's no derivative there and everybody gets it wrong.
I'm ready.
The derivative is an important piece here. Second fundamental theorem of calculus establishes a different relationship between derivative and integrals. Okay? So let's do one quick problem together and then give you guys some time to practice. And then we're going to move on to the free response. All right, here we go.
Torture.
All right, bet you guys want to feel good about yourselves here.
Didn't we eat?
All right, number one, f of x is the integral from 2 to 2x, 1 over the square root of t squared plus 1. Find f prime of 1.
There's no derivative.
There's no derivative. Good. Good, you're not going to fall for it then, are you?
No, not this time. Not this time.
Except, Anthony, what is it that I want you to find?
F prime.
Ah! I want f prime of 1.
I think you put as t cubed.
T cubed, thank you. Okay? I want f prime of 1. This is a two-step process, and I need to see both steps. The first thing, you need to find f prime of x. So derivative integral from 2 to 2x, 1 over square root 2 cubed plus 1 dt. God, it takes me longer to write that than to write the answer. 1 over 2x, the whole thing cubed plus 1 times 2. Everybody okay with the setup? Yep. Okay, f prime of 1, you know what to do. Plug it in. 1 over square root of 2 cubed plus 1 times 2, 2 cubed plus 1, that's 9, square root of 9 is 3. I think we get a third times 2, 2/3.
Oh, it's on the front.
You're okay. Everybody good with the 2/3? Would everyone agree this should be, for the 7 of you all, a pretty comfortable, easy question right now? Good. So I want to make you groan a little bit. Okay, you get the next 8 minutes. Show me what you can do. You can work with anybody in the room that you would like to. Roger, feel free to Google if you have to.
Roger,
All right.
I'll work with you.
Work with Notre Dame?
Let's kind.
Questions 2, 3, and 4. These are trickier. They're going to push you more. They're going to push you real good. My phone died.
Struggle.
It's trying to fight against the dying.
check out
No, but the thing is like where you're 2 and 2 or something. Right here, right? Are you using just
I was
enter-
looking for it too.
Yeah, so what's each open to the 2?
Oh, okay.
0 plus 0.
Right. You could have gone the route of let me go find the antiderivative and then plug in and then you get 0 and then you get angry and you punch the CO. Knock my camera to the ground.
Check it.
Nice, keep going.
What? Madam.
So f of 2 is fine. What's f prime?
You know, Brian could joke.
Oh, wait, it goes back.
Brian will choose to see.
So f prime is going to be 0 plus. Oh. Look at what you did. You decided that you don't want to use the second fundamental theorem of calculus. Why? So mistakes over here.
The viral form.
No.
Final part of 6 is agree with
The second fundamental theorem of calculus, which I've so cleverly erased. Derivative of the integral of the function. You just plug this into the function. You don't change the function.
Did you get it from the final equation?
Is everybody good with E? Yeah,
That's
you're good.
6. Yeah.
Okay. And please keep in mind, I picked ugly questions here.
The person down make it quick.
Ooh. Yeah, just use it.
To find
Okay.
derivatives or to get
I just think of this as x. Well, not x, but like it's something.
Okay.
And then, as I'm looking for the tangent line, I have to find the derivative for the tangent derivative of all this.
Yep. And so hopefully that's the easy part, because we just know that the derivative and the integral cancel out.
I just looked at it a little teaser.
So you've got 4x sine of x over 3. I agree that is the derivative, but what you need is you need to be able to write the equation of the tangent line at pi over 2.
Sine pi over 6.
Don't tell him, make him work for it.
Sine.
Don't tell him, Lucio.
Stop.
Who are you more afraid of?
Sensei.
So f pi over 2 is 0. Okay,
Jesus,
I got negative.
What's
Sine pi is
play around with it to get into their form.
So
Okay, so you guys had to find f of pi over 2, like big F of pi over 2.
It's sine
And we got-
pi over 6.
And
I
then
know.
big F
It's
prime,
really-
that's when you finally had to use your second fundamental theorem of calculus.
Yes.
Okay.
Okay, so 4x sine x over 3, and pi over 2. And so when you find f prime of pi over 2, I think that's where the mistake's coming in. Yeah, that's the mistake. That's the mistake.
So equal what?
You've got x divided by 3. You're plugging in pi over 2, that means you need pi over 2 divided by 3, not times 3. F prime of pi over 2 should be pi. Okay.
Just use the.
This is a nasty mother of a question. Okay. Like getting here is fine.
What's your y value?
Clearly you know what to do. You know, going from here to whatever their answer choice
What's your
is.
y value?
It's pi. Good. Right, then it's just a matter of manipulating some algebra. Since there's only about 2 minutes left, I want you guys to try number 3, see what you can do.
So return to this.
And you know what, I'm not gonna have you worry about going any further than this. Did all the stuff to get here make sense? Good. Right after that, it's algebra manipulation, it's not calculus, I'm not as interested. So show me if you can do this last one. We've got about 1 more minute.
One is incorrect, one is wrong.
I just remember something. At Spanish, just said that.
Did they say get to work? Did they say son casos? Mm-hmm.
This was gonna be your expectation.
Wait, wouldn't it be false? Wouldn't it be false? The bigger, so when you have a bigger number, the number on the bottom.
You give me all time.
One fall.
You're gonna blame me for that.
Here.
What have we decided so far in number 4?
Yeah.
The statement 1 is incorrect.
Statement 1 is incorrect.
Oh.
You're right. Statement number 1 is false. Because what is big F of 0?
Big F of 0, just to be here.
Big F of 0 is 0 because your limits of integration, you're going from 0 to 0. You've accumulated no area. Good. Big F of 2 is less than F of 6.
Incorrect.
How did you make that decision?
Because you know how you should have like the bigger number at the bottom should be like the lower area. That's basically how it's
But when you talk about big F of 2, you're saying how much area from 0 to 2 is bounded by that function in the x-axis. Big F of 6 is take the same function. How much area is there from 0 to 6?
then I'll actually get the number.
Right. We're not talking about the y value of the function. We're saying how much area. If I start at 0 and I'm allowed to go out to 2, and I compare that to how much area from 0 and I go all the way out to 6, that's what I care about.
Yes. But right now.
So now we're down to B and B.
All right, I hate to do this to you guys because we've only got about 18 minutes left, and I want to make sure that we capture Roger for the last 18 minutes here. So the answers are, number 2 is E. Number 3 is C. If you didn't get to that actual multiple choice answer, I know that everybody at least came up with the equation of the tangent line, and that's the part that I care about. Statement number 4, question number 4, the first statement is false. The second statement is true. The third statement is also true, and it should have involved finding some amount of derivatives there. So the right answer would be D. Okay, right? Because to talk about f double prime of 0, first you find f prime of 0, which is the second fundamental theorem of calculus. Then f double prime means now you need to take a derivative of that, and you use the quotient rule. Okay. I deliberately picked nasty, ugly multiple choice questions here. These are harder than anything I would expect you guys to see next Monday or next Tuesday. Okay? We've got 17 minutes left, and here's what I'd like to do. In my mind, I was going to give you guys 5 minutes to work completely on your own on this, but then that's just more dead time for Roger. What I want to do is, let's do this. this free response question, this came from the 2011 AP exam, it's question number 4. I did not change a single thing on this question. Nothing needed to be changed on my part.
So we have done
This is on the AB.
This was on the AB exam. This one's mean. This one's really, really mean. So, I want you to take a minute, read through this, plan your attack. For those of you that after you read this, you're like, I feel good about this, I'm just going to ask you to move to the back and continue working through this on your own. Hopefully 1 or 2 of you will stay with me and Roger, and so we'll be able to continue the conversation. Alright, continuous function f, defined on the interval -4 to 3. The graph of f consists of 2 quarter circles, that's probably important, and a line segment. As shown in the figure above, g of x is equal to 2x plus your integral from 0 to 6 of f of t dt. Find g of -3, find g prime of x, and evaluate g prime of -3. That's worth 3 points right there. 3 points right there. All right. Nathan, how do you feel about finding g of -3? What are you going to do?
Get the first one.
Okay, what does that mean?
I said g of 0 equals g of -3 plus the definite integral of -2 to 0 d prime of x.
Okay, so I heard you say that g of -3 is going to be equal to g of 0 plus the integral from 0 to -3 of g prime of x. And I'll tell you, that is true. The fundamental theorem of calculus would agree with you on this. I'm not 100% sure where you're going with this, though. Do you have a plan in mind of where you're going? Okay, what are you doing from here? Because there's a much easier way to get g of -3.
the fundamental theorem. If definite from A to B fx equals
Yeah, I'm not saying that this guy over here is wrong, but they told you what g of x is. Just plug in -3. So g of -3 is going to be 2 times -3 plus the integral from 0 to -3 of f of t dt. This part's easy, right? The -6. But how am I going to find the area from 0 to -3?
Function f of t and the area to be 0 to -3.
Right, I need the area from 0 to -3. And we've had these conversations before. How am I going to find that area from 0 to -3?
It's 1/4 of a circle.
You know it's 1/4 of a circle, right? They told you that you've got a quarter circle here. So that means that this area is going to be pi r squared, but only take 1/4 of it. So we're going to say that's -6 plus 1/4 of pi. What's the radius there? Is that 3?
Yes.
3 squared -6 plus 1/4 of pi times 3 squared?
9 pi over 4.
Or who cares?
Oh, yeah, sure.
Who cares? It's free response part of the exam. No, so sad. That's
Right.
wrong.
Oh.
You guys all let me get away with that.
Because
Oh.
Yeah.
Victoria,
like,
where's my mistake?
I was confused that Brian said that because since we're taking the derivative of f of t, or
Whoa.
since we're doing the definite integral from 0 to -3.
Definite integral from 0 to -3. What's the
wouldn't
problem?
To me, that makes sense that we're talking about the area of the derivative. I mean, of the antiderivative of f.
F of t is your function. This is f. What's the issue, Anthony?
Isn't that f of x?
Okay, but whether you call it f, okay, we've had this conversation before. Whether you
Aren't
call
we
it f
moving-
of x or f of t, you're just changing out your
We're going
independent
from,
variable. You guys are going big brain, and it's a small
from
thing.
0 to -3.
There you go. You're doing an integral from 0 to -3. What's the significance here?
Oh, then it's fine.
And it should be negative.
Right, this has to be a negative area there. Okay. Victoria, are you okay there?
Yeah.
All right, things are going to happen quickly now. G prime of x. They are being so kind, so kind. They're saying, hey, go find g prime of x first. So we're going to go take a derivative. We're going to find the derivative of 2x plus the integral from 0 to x of f of t dt. I hope everybody's seeing second fundamental theorem of calculus here. But be careful. Be careful.
Isn't it
Do you
2
separate
plus-
like?
Oh yeah, separate.
Right, you're taking the derivative of this plus this guy over here. So it's going to be 2 plus f of x. So g prime of x equals 2 plus f of x. There's another point. And then g prime of -3, so that's 2 plus f of -3. What's f of -3? F of -3 is 0. So we just get 2.
Do we need to solve for f negative 3, or can we just put f negative 3?
Well, you cannot just leave it as f of -3.
Okay.
Okay. And it's a really good question because you can leave numbers. You don't have to simplify numbers. This isn't a number yet. You still have to do some evaluating. You have to go to the function and say f of -3 is 0.
So what about f of x and the g prime of x?
Well, g prime of x, this is they're asking for a function. This is just a function. It's not a number yet.
Oh, okay.
Everybody okay?
Yeah.
Now, here's the thing. I just graded a whole bunch of exams. Let me show you what I saw happen. They did not do this problem exactly, but it was close, and there's some bad habits that they're picking up. I'm not sure where these bad habits are coming from. Okay. Bunch of AB students working through the problem like this. Is it true that g prime of -3 is 2? Yes.
Oh, I know it.
What's the problem?
It's supposed to g prime of x.
They are making, it's called a linkage issue here. They're telling me two things are equal but are not equal to each other. G prime of -3 is 2, but g prime of -3 is not this.
Yep.
What is equal to all this?
G prime of
G
x.
prime of x. Right, so I think that the College Board, they were being really kind by saying, first, go find me g prime of x. Second, go find me g prime of -3. Okay, I will tell you, the kindness in this problem is over now. They're done. There's no more kindness coming. Okay, B, determine the x-coordinate for the absolute maximum. Ooh, absolute maximum.
Oh lord.
G has an absolute max. That probably like puts fear in your heart. Absolute max. What are we gonna do?
Optimization.
Endpoints and
Yeah, instead of can.
Okay, something about candidates, something about
Optimization.
optimization. We need endpoints. We need some endpoints here.
-4, 2, 3.
Okay, are those the endpoints actually?
Yeah.
Number 4 and
Okay, your endpoints are -4 and 3. I agree. You need a candidate. If G is going to have an absolute max, that means you look for where G has a relative max, which means G prime changes from positive to negative. Okay, that's just what our candidate means. It's like the relative version of what we're looking for. Where does G prime change from positive to negative?
Between 1 and 2.
Between 1 and 2? Why are you saying that?
Because
I think I know why you're saying that. Tell me why.
isn't g prime equal to f of x?
No.
Isn't G prime equal to f of x?
G prime is
No.
equal to 2 plus f of x.
G prime is 2 plus f of x.
Yeah.
Right, they are setting you up, Anthony, to think that this is your candidate because this is when your graph changes from positive to
So we
negative.
subtract 2 from that?
What you're going to have to do is get a little clever here. What are your thoughts?
I was gonna say just shift the graph upwards, kind of.
Okay, right. If this is the graph of f, well, what's G prime? G prime is this graph plus 2. This graph shifted up 2. So either you redraw the graph and say, let me shift it up 2 spaces, or another clever thought,
-1.
-1.
Oh wait, no, wherever the equation f of x equals 2.
Not where it's equal to 2, but where it's equal to negative 2.
Yeah.
This guy right here, when the graph of f changes from being greater than negative 2 to less than negative 2, g prime is going to change from being greater than 0 to less than 0. It's a little tricky here. So where's that point? Where the heck is that point? Well, let's see. What do we know for sure? I know this point is over here at 3 comma negative 3. I know this point up here is at 0 comma 3.
So it's just changing by 1, so it's just being
But it's not changing by 1. Right? If I look at the line that connects these 2 points, that has a slope of, you go down 6 and over 3, and so this has a slope of negative 2.
So do we have to make an equation?
So I would maybe make an equation and say the equation of the line is y equals negative 2x plus 3, because that's the y-intercept. And then you're asking the question, where is the y value equal to negative 2? So negative 2 is equal to negative 2x plus 3. X equals 5 over 2. Not the thing anyone's going to guess. You're not just, oh, I think it's 2.5. Okay? But what I would encourage you guys to do is if you're like, hey, I'm not really sure where the candidate comes from, what else would you do?
just use the end.
Maybe you do the number line test. I would hope we'd at least evaluate the endpoints, right? You'd like plug in the endpoints and you say, well, what's g of negative 4? Oh, I'm supposed to go back over here and plug in negative 4 and get my integral and go from there. Okay. Let's put a pin in part B and move on. Part C. Part C, I can't see it anymore.
So find all values of x on integral negative 4 to x.
Point of
Which
inflection.
graph of g has a point of inflection.
Ah, G has a POI. Points of inflection. 3 options for proving a point of inflection.
It's G
Okay.
prime.
Okay, about to the point now.
No,
Okay, I'm gonna freeze you.
derivative.
Three ways. Jose, give me one and then you're frozen.
Concave down to concave down.
G changes concave up to concave down or concave down to concave up another way.
G prime changes from increasing to decreasing or decreasing to increasing.
G prime changes increasing to decreasing, decreasing to increasing. Third way.
Double prime changes sign.
G double prime changes sign. These are your 3 options. Choose the one that makes the most sense here. If G has a POI, I don't even know what the graph of G looks like. It doesn't make sense to talk about concavity. If we want to have a conversation about G prime changes from increasing to decreasing or decreasing to increasing, well, can we figure that out?
Yes.
Where would G prime change from increasing to decreasing?
X equals 0.
It's going to have to be at x equals 0, but at x equals 0, that's where f changes from increasing to decreasing.
Is
But
it
you
just
also
adding
added
2?
just-
Yeah.
Right, G prime being f of x plus 2 just says take this graph and shift up 2 more spaces. So where do I change from increasing to decreasing? Still at x equals 0. Where do I change from decreasing to increasing?
Nowhere.
Nowhere. Okay, so this is going to happen at x equals 0. All the friends were okay?
Yes.
All right. Oh yeah, they give a point for that. You got like a point over here for g of negative 3, a point over here, a point over here. I think this whole hot mess is like 2 points. All right, D. Oh, love D. Find the average rate of change of f on the interval negative 4 to 3.
Definite integral.
Average rate of change.
Yeah, definite integral from negative 4 to 3, the equation, and then over those intervals.
So I'm hearing from lots of the friends that we want to do something like that.
Yes.
Yes.
What's the function? Careful. Careful. We're about to blow it. I can feel it. I can feel it. The wrong thing is going to come out of the collective mouth.
But
Go back and read the problem one more time. What are we finding?
find the average rate of change of f.
You have a beautiful setup here for average. That setup there is focusing on the word average in isolation from all the things that come after it. What am I finding the average of? The rate of change of f. So what you guys have me doing here is finding that integral.
Is that what?
The integral from -4 to 3 of f prime. I was not hearing f prime coming out of any of the mouths.
Yeah.
I think you guys were going to tell me f, not f prime.
I did.
Right? That setup was just for the word average. Average velocity, average speed, average whatever. Now I need rate of change of f, that's why it's f prime. Well, what's the integral from -4 to 3 of f prime of x?
Isn't it,
Yeah.
isn't it just 1 over 3 minus 4 parentheses? How did I explain it?
Okay, we're going to change that to 7 because
So
I'm
1
tired
over
of it.
7 times parentheses, just f of 3 minus f of -4.
F of 3 minus f of -4. In fact, I'm going to keep it written as 3 minus -4, even though I said I wasn't going to. Where is this coming from? Antiderivative of f prime? F. Plug in 3, plug in -4, subtract it. Look at this with fresh eyes. Look at this part over here with the fresh eyes.
Yeah.
F of 3 minus f of -4 over 3 minus
Wait, isn't that
-4.
just the average rate of change, like the rate of?
I'm sorry, can you say that one more time?
I said it wrong.
No. Say it one more time so that all the friends hear this. What is this?
Average rate of change.
The average rate of change. Go back and read that question. What did they actually ask us to find?
The average rate of change.
They actually used the whole phrase average rate of change. But you all stopped reading as soon as you saw the word average. You looked at average in isolation versus looking at average rate of change of f. Hold on, I see. This is just average rate of change of f. And then you tell me what's f of 3. Well, what's f of 3? -3, sure, make me do all the work.
Yeah.
F of -4 minus -1 over 3 minus -4, which is 7. So -4 over 7. That's the average rate of change of f on that interval. Now,
Isn't
this
that
is
-2?
who knows? Okay, don't embarrass me in front of the guys here.
Okay.
All right, then it says there is no point C at which f prime of C is equal to the average rate of change. They're making a statement. Explain why this doesn't contradict the mean value theorem. Mean value theorem. Mean value theorem. What's your question?
Yeah, I have the answer to it, but I just want to make sure.
Why don't you whisper it to me and then you can go? Yes, come on. Why is this not a contradiction of the mean value theorem?
It's not differential in the open loop.
What's the it? What's the it?
This one.
What's the it?
F
F of x. The graph that I'm seeing is not differential. Anthony, how do you know it's not differential?
There's the, how do you call it? Not the setup point, the,
Cusp point.
their cusp.
Cusp point. Where's the cusp point?
X equals 0.
Okay, there's a cusp point at x equals 0. Okay, before you totally take off, tonight for homework, there's no formal like picking up homework, but I would strongly encourage you guys to do one of these practice problems tonight for homework. Just go deep, know that these are ugly questions. See you guys tomorrow. Oh.